And what I'm looking for now is to see if I have any, injection, because you can inject DLLs into an image, and the goal of doing that is so that you would think you're playing calculator, but inside of that calculator there's been an injected DLL. Okay, it's like you think you have a calculator, but you actually have a malware or a rootkit inside that calculator, can be injected into it. So one of the things we're going to be looking at over here is to see if you can see loaded DLLs, to see from there we can find something that is abnormal, and that is very essential in order for us to be able to kind of see if the malware is trying to conceal DLL. You will remember one of the things I told you earlier on about, I'm going to pause it over here. I'm going to try and look up to see if I can show you doubly linked list. If I can find anything, this one looks like it might be good. So this is what your doubly linked process looks like. So you can see the head, the backward, sometimes they call the one the fling, and then you have the blink. So, and this is what they look like. There's another diagram that I want to show you if I can find, if we can find something that really capture the picture that I want to show you. I want to see if I can get eproc out here. Process. Yeah, this looks more like it. Let's see if I can get the picture out. I saw a picture there earlier on that looks okay. So here is what I want you guys to see here. I'm gonna, so look at it. So this structure here, show you exactly what each process looks like. This is a data structure. You can see the fling here, and there's a blink. See, blink, that's B-L-I-N-K, and this is flink. The one in the front, the one that goes back. And this is a process now. This is another process. This is another process. That's how they're linked together. If the bad guy wants to hide this process, all he's got to do is to break this link. So now you're going to see this blink of this process here connected to this one instead of this one, and then the fling of this process go over here and connect to this one, and this process will be hidden. When we run PSCAN is not doing what you normally expect it to do by coming over here from the PRCB and follow the current thread and look at the each thread and then run through the normal trace and then go from here and then run through all the entire link. Rather, what your PSCAN does is to look for any data structure that looks like this, whether they are linked or not linked. Does that make any sense? In the same length, you also have DLL. There is a function in your Windows system called load libraries. And that is how libraries are loaded. So when I run a process, inside this particular process, you have several libraries that are loaded. Okay? Those libraries are also linked together, just like process are linked. However, just like process, they don't have to stay linked to work. You understand that? They could be unlinked. So it is possible, if it works normally, I will be able to see all the DLL that are loaded by this particular process. And I can see all the DLL that are loaded by this particular process. However, if somebody injects a DLL into your calculator, how am I supposed to know that a rogue DLL has been injected? Because if you see a process running, it shows you calc.exe. You say, oh, that's my calculator. How do you know a rogue DLL has not been injected into that process, so that you can have like 50 DLL running within a process, right? And you say, well, you know what, this particular DLL is not supposed to be there. Because bad guy uses that a lot. That's how people get in trouble. They downloaded a particular game. The game itself is good game, but it's been injected. There are bad DLL loaded in it that is going to make it misbehave. Now, instead of a calculator, you have something that's also collecting your data and calling back. Does that make any sense? So how we look for that is one of the things I'm going to be going over a little bit later with you guys in the class. I just want to kind of show you guys this diagram. So if I run this over here and I say Dlllist, if I press enter here, you will see that volatility is going to show me all the DLLs you're going to see it here. These are the loaded DLL per process. Let's go back all the way up as far as I could go. We'll see. Look at this particular process here. Run DLL.32.exe. Here's a process, but look at all the DLLs that are loaded by that particular processor to perform, or process rather, to perform one task or the other. You can pipe it into less here if you want to see them by paging out. Now you can see from here where my trying to see where my commands start from. I'm going to clean up this one right in a second. So you can see what I've got here. I have a process here, SMS, and your system generally is at the top. Unable to read the PEP for this particular task, that's okay. Remember, your PEP is in the user area, okay, not in the kernel. And then you can see that for the next process here. My bit device is dying. I'm going to have to reconnect back to my bit device because it's disconnected. But you can see the process here and look at the DLL that were loaded. So you can see that all these program services, they all have DLL that they've loaded. LSAS, they all have DLL that they've loaded. And this is where your password is. LSAS. Okay, that's a process where your credential is actually stored. If somebody were to cache this one, they probably got you. You know, it wouldn't do you any good, fighting. So you can see, you can look at all this stuff and just kind of run through them and look for if you have anything that might appear malicious. Now let me go ahead and use let me go ahead and use, having explained what DLL is for you, let me go ahead and look for anything that might be malicious, because in that case I'm just going to come over here and type Malfind. Okay, Malfind. I'm going to pipe into less so I can page it. And you can see what it's doing over here. It's saying inside this place I found something that looks bad. Okay, and the flags, protection, VAD tag, I already told you guys what that is. Okay, and it's up to you to look at it and see if they are indeed bad or if they are not bad. I'm going to save you some time over here and quickly jump to the one that most likely are bad. And you can see the VADs I told you about. Those are, if you find that, that is generally, bad. So I'm going to go all the way down to see if I can look at this. This WinExplorer.exe. One of the things that you want to do is a guy called Michael Hale had already looked at this process, Explorer.exe, and looked at normally what DLL is loaded, you understand, into Explorer.exe and capture it, so that if you see something that is normally not loaded, in other words, things that are not whitelisted, then it's likely going to kind of flag it. And generally when you see something like that, especially for the Explorer.exe, you want to take another look at it. Something that is interesting here is you can see how it actually print out the data view of that particular area, and also it shows you the video here just to, okay, so that's one over here. There's another one that I'll show you real quick here before you start your exam, is Printkey. Okay, and what you get with the Printkey is to examine the registry content on the image. Still loading here. There you go. And having run that here, here's what I get here. You can see it's showing me all the registry settings, or registry content on my memory. See, all these are ntUser.dat. I can potentially look at how many users are created on this system. Look at the application, sub keys. This provides me with, this is where your account, your password is stored in your security account manager. This provides me to a lot of valuable information. But then I can get really more detail. You remember that when I did this earlier on, go back here, go to less here. Let me show you something here real quick. I have all these things, but it really doesn't tell me a little bit much. If I want to know more, I can actually specify this key. Now I'm saying I'm interested in a particular registry key, and I can do this. Type Microsoft, for example. Okay, and I can go to Windows. I can go to current. I can go to current version. and I can go to run. And if I do not fat finger anything here, look at what I've just done. Can somebody tell me what I'm interested in at this point? What do you think I'm looking at in this situation now? I'm looking for files that are what?
Registry file?
Yes, what are registry files? Just look at this. Look at the key. What am I interested in? Huh? Close. I'm looking for. Huh? Not necessarily. I'm looking for persistent programs. Programs that automatically run every time my system is restarted. What does the bad guys like to do? They like to be persistent, right? So that you think something is wrong with your system, and I'm recording this, so it's going to be on the video. You can upload it after the class. Alright? So, what does the bad guys like to do? Bad guys like to be persistent on your system, so that if you think something is wrong, and you delete it, or you restart your system, as soon as you restart, what are you going to see? This program is going to begin to run again. So one of the things you're trying to see here is I want to see programs that are persistent on my system. Like, does this program look familiar to you? No? Okay, well, let's go back here. Let me refresh your memory here. Sure, we can all use a little bit of refresh. I'm sure I found that program before. I'll go so you can find it. If you find it before myself, let me know. But I'm pretty positive that I've seen that coming before. Look at it. You see that? You see that? Now, when I see it over here, and then I come back and I see it over here, what does that tell me? You're beginning to have a story. Remember what I told you about in the class? It's not that you want to go tell a technical program, is that we want to tell a story. Any questions? Alright, so it's a 2:05. I'm going to stop here.